All right. Today we're going to start chapter 1, section 1, intro to problem solving. How does the activity we did on Monday, how does that relate to problem solving? What's that?
Said in every way possible.
Exactly. It was a problem. I gave you a problem. It was an activity, and you were supposed to solve it. And in reality, the problem was, how do I get the most candy? Build the tallest tower. So we're going to do here, we're going to look at the 4-step problem solving. It was developed by a guy named George POLYA, who is considered as the founding father of the problem solving technique. And then we're going to look at various examples of how to solve problems. So who's George POLYA? He was alive in the 1800s. He was born in the 1800s, 1875 to 1985. No, 1885, I believe. About 100 years old. He came up with this 4-step process. That applies to every problem you have. And it has, since then, it's been expanded to like 5 or 6 or 7 steps. The first step in any problem is what? Before you start anything, what do? Right. Understand the problem. Analyze situation. Step 2. Because in the understand the problem, you have to see what you're supposed to do, what you have, and how do you get there. What do you think step 2 is? They're good. Devise a plan. Because when you devise a plan, you pretty much work through all different types of scenarios. If you're building a house or a building, what equipment do I need? What if this happens? How do I fix it? So you can see what you may need and have a contingency behind it. What do you think the 3rd step is? You understand the problem, you devise a plan, now what? Carry out the plan. Yeah, because when you're devising a plan, yeah, you get all that stuff, and now you carry it out. You get all the material, you get everything you need, and you start building. Now what do? You're done with the plan. What do you do now? No, that's where this is. You're solving it here. This is the solving part.
Find out how you can do better next time.
That yes and no. I see what you're saying, but in other words, if you're building a building, somebody paid you $10 million to build a building, and it's leaning over. So, I don't think we should use plastic on the 10th floor. So, and then that person's stuck with the defective building. No, that's so you can't really do that. I mean, you have to look at, is it the best solution? How do I put this? Is determine or evaluate the solution. What this means is look back. I mean, you were right there. You said, see how we can do better next time. But you're never done with a project until when? It's the best it can be. If you ever wrote a paper, How many of y'all wrote a paper for a class only one time and turned it in? Yeah, in reality, you probably failed that paper. Because no one, not even the best writers, not me. I mean, I've been writing articles and I can never do that. It's impossible. Because if you go back and look at it again and reread it, you'll see how jagged it is. It's not fluid. It's not precise. Does each paragraph lead into the next one like it's supposed to, which are in English? No, of course not. When you're putting together a paper, you just most of the students do now is just copy and paste and try to paraphrase it. But that's again, if you took your paper and submitted it to publication, if you think it's that good, then it'd be published. As opposed to if it's not that good, it would come back to you and says, please don't send this back to us. We have a headache. No. A true paper, if you're truly doing what you're supposed to be doing, you would write your paper, reread it, make corrections, reread it again, see if it's addressing all the issues. Have somebody else reread it for a fresh set of eyes. Because the stuff that students turn in today, I mean, you can tell it's done in a hurry. And in reality, you shouldn't be proud of that. You should go through and again, everything's a problem. Like a paper, that's a problem. You have a problem. Are you happy with the first time you build it? Then if that's the case, build your house one time without looking back and then move in and hope it stays up. Kind of like the 3 pig story. The first pig built this house out of straw. It stood up. It was happy. But did he look back at it and say, is that the best building I could do? No. What happened to that first pig? In reality, he became food. Same with the second pig. Third pig took time to think about it. Said, okay, what am I going to build that keeps the wolf out of here? And it'll keep on standing. How did he build his? He built his with brick. That's the way you should address and approach every problem. And don't try to get away from writing, because as you get further in college, you guys all want to have careers as educators. Do you want to read students' work that's blah? No, you're going to want them to write the best. So you cannot expect your students to do something that you don't do. So if you expect perfection, you have to give perfection. And there's the big dividing line when it comes to what's expected from students and what's expected of teachers. So these are the 4 steps. Actually, the interesting about this is there was a guy named, what's his name? After World War II, Japan was destroyed. They had nothing. So this one person who started off with this and added on another step, he said, a problem is never done because once you finish it, look back. Is it answering the problem? Is it answering every part of the problem? If not, a problem is never really fixed. In computer programming, a program is never finished being fixed. Why? Because the problem changes. So you should always have a recursive process. Always look back. All right. So here's what George POLYA said. Here's what he said. Solving a problem means finding a way out of difficult out of difficulty. a way around an obstacle. Attaining an aim which was not immediately attainable. What does all that stuff mean? Solving a problem means finding a way out of difficulty, a way around an obstacle, attaining an aim which was not immediately attainable. Finding a way out of difficulty. What does that mean?
It would be like trying to solve a problem the easiest way instead of like the hardest and longest way. Trying to find like the shortest path.
No, that'd be cutting corners. That's you don't want to do that. But you're close to what you're saying. Is every problem has to have a solution. There is no problem in the world that doesn't have a solution. You just have to find it. Maybe not you finding it, but with your trial and error, somebody else will use your information and find a way out around it. Case in point, electricity, light bulbs. For so many centuries, people have been trying to figure out how to make light last longer than a candle or a oil pot. So they kept on working on ways. And then eventually, well, it wasn't really Edison, but it was one of his minions that discovered it, and he just took credit for it. But yeah, with trial and error, trying different, try different things. You try the stuff you try first. He tried aluminum, he tried steel, he tried tin, tried copper. And then he tried stuff like silk and leather and things like that. And eventually he found some combinations of those things that did work that you never ever thought about. So it's difficult until you find a solution. Then when you look back, you said, oh, that was easy. Same in mathematics. Any problem I give you, you can solve it with knowing the basic rules of math. Once you solve it, you say, oh, that's easy. I should have known that. But getting there is the same problem, is the issue. Attaining an aim which was not immediately attainable. That statement is kind of a duh, because if it was attainable, then it wouldn't be a problem. By definition, any problem is not attainable at that time. When you get to your classroom, and you'll have all these kids, if you're teaching elementary school, you'll have so many difficulties, so many problems. The kids don't want to learn. The kid has no support at home to learn. So the rest of the class moving forward, at least one or two students are falling behind. So how do you get them to catch up? These are kind of problems that you'll be faced with every day in your career. And the more you know about education and solutions, you'll figure out a solution. What's the best way to solve it? How would you do it? If a student is falling behind, how would you bring them up to the rest of the class? Remember, you have to treat the kid fairly. You can't stand them up in front of the classroom and says, you're falling behind, you better catch up. You can't do that because that's embarrassing the kid. What would you all do if one kid in your class was falling behind? Okay, that's a possibility. Anybody else?
Just provide senses in the sentence.
So bribe them. See, that's the worst thing you do. Because kids nowadays are always expecting a reward for something they do. What happens if the reward doesn't come? They'll stop doing it. Why should I do this if I'm not, if my dad gives me $1 for every time I take out the trash, if he stops giving me $1, I'm not gonna take out the trash. Incentives are always the worst way of attaining solutions. You're only prolonging the inevitable. So, yeah, unfortunately, that's the generation you're growing up in. Is last. So let me. I'll give you. I'll give you pay you this, or I'll let you do this if you do this. It's called a quid pro quo, something for something. Worst way to solve. Remember, understand the problem. Did y'all even bother finding out what the problem with the kid is? Do all kids not want to learn? No, actually, on the opposite. All kids want to learn. That's what they're built for. They may have other issues going on. For example, my wife had students where all of a sudden they just shut themselves out in the class. Why? Because their dad just got arrested and went to federal prison. Or mom is now in the hospital because of a car accident. Or granddad died. So there are other extenuating circumstances that are not apparent unless you find the problem. You have to sit down and find out what's going on. Talk to the kid. And then from there, once you understand what the problem is, then you can go on all these. So yeah, the kid's having a very terrible time, and you're just giving him more work to do. He may just need somebody to talk to. So again, it's not always that simple. All right. Problem solving includes 5 standards. So when we do a problem, what are we trying to solve for? Bless you. Representation. Reasoning. Solving a problem. Communications. Connections. Let's look at those. How does this relate to the stuff we did on Monday? What is representation? What does representation mean? Mm-hmm. Yeah, in a nutshell, that's what it means. It's to have something, because if everybody had the same representation of the problem, every one of y'all had the same building last week or last class. Did y'all have the same building? No. So again, it's how you perceive, how you represent the problem in your head. Reasoning. This is a big one. Reasoning. What does that mean? What does reasoning mean? Reasoning is using common sense and logic to attain a solution to your problem. So, in other words, example, your buildings, your structure last time. Would reasoning tell you I can't start off with one spaghetti stick and then build on top of that? Can you do that? No. Reason tells you what? It's not support. It's not sturdy. So I know most of y'all, if not everybody, you start off with a square base, with a solid base, and then built from there. Problem solving, that's just this. It's just that you have to solve a problem. Not only just a big problem, but each step along the way is its own problem. Because when you guys started building your towers, what happened to it? Started tilting, started rotating. Those are each smaller problems that you had to solve in order to get a bigger solution. Communication. Except for that group of three, one person was really quiet. Did they ever let you say anything during your construction? So, so at the end, they listen to you. Yeah, communication is muy importante. Because if you don't understand what the problem is, what do? Ask questions. And you all did that in a sense. Along the way, said, well, can we do this? Can we do this? But some of y'all didn't ask questions and started using the marshmallow as a connector. Even though I said in the instructions, here's a tape. Only thing you use the marshmallow for is the highest point. Is it bad? No. Always think out of the box. I think it was pretty ingenious using the marshmallow, smaller pieces of it as the base. And from now on, I'm going to start letting students do that because that'll give a solid foundation instead of using tape. Connections. What does connections mean?
Like saying, have contact with people, know how to buy properly, you know, get the cheapest material. You just know who to
Okay, yes, you have those kind of connections, is getting information and resources from outside. Yes, that's one. Very good. What's another form of connections? Exactly. If you built a house before, can you use what you've learned in the previous one to the new one? Yeah. Connect what you know in the past. Because what you said, but you're connecting their prior knowledge. Connect with your prior knowledge. And then do both. If you do both, that's the way you're going to learn. I mean, yeah, it's the first time I ever built a shed. Yeah, mine did the same thing yours did. Because I didn't know when you're building walls, put the diagonal in there to keep it up. Brace it up on the sides. And it was a little bit more expensive than spaghetti sticks. So after I tore it down, I had to start again. Again, connections. Connect each step with what you know in the past will work. And then if you don't know, get somebody else. Which is what's great about Home Depot and YouTube. If you're going to do anything, cooking, fixing a car, cleaning your house, your connections, use prior knowledge. Because once you try it, now think about it. Once you try it and do it, you have all that stuff that other people told you about for the next time you're going to get approached with this. Buying a car. That's probably the most scary thing in the world for you, next to buying a house. Because you have one shot of spending a couple of dozen $1,000 to something you're going to be stuck with for a very long time. So, okay, what would be the process of buying a car? What would y'all do first?
think I'm like, let's look around my apartment, see where I live at, because I live in a bad area, I'm gonna buy like.
A good, yeah, that's a good point. That's a very good point. But then again, if you buy, you get what you pay for. But you're right. You're very right there. And unfortunately, that's a reflection of society. Because we have politicians who are lawyers and they make the laws for the criminals instead of people who are the innocent people. You said, is the person who gets caught stealing a car, what happens to him? they go to jail for at most a couple of days because the prisons are crowded, so they get out. What do they do again? Back to another car. If they get away with it, they make money. If they don't, they just go someplace to get fed for 3 times a day for a couple of days. There's no punishment in crime nowadays. It's a reward. So yeah, so look at the environment. Okay, let's say you live in a good neighborhood. You're gonna buy a car. You're living in your dream neighborhood in Bel Air, California, near Hollywood.
I mean, well, what do we- Right, like,
Do people do that nowadays? I agree with you. In the past, yeah, that's what we look at is let's look at the gas mileage first. But if you look at the gas mileage of the best gas mileage, what do those cars look like? A little small thing. It's so do you want to get caught driving one of those? Yes. Yeah, very good. Yes. You don't have gas mileage, you just have distance traveled on a charge. But what's the problem with electric cars? What's that? You have to find a place that you have to charge up, yeah. And because the government is making more money, giving more money to those, you have more and more charging stations around the world, around the nation, like at grocery stores. Tom Thumb, a lot of those have charging stations and malls and stuff. So yeah, again, that's true. So where can I, if I'm going on a road trip, would it be advisable to go through the desert on an electric car? Because if you did find a gas station, is it going to have electric port to charge from? No. So now you're stuck with a dead car. And just conversely, if you're in a cold environment, batteries die faster in cold environments. So if you're used to driving 200 miles on a charge, in wintertime, it drops. So yeah, so you look at that. So you look at those. Do I get an electric car? Do I get a gas powered car? Or what's in the middle of those two? What are those called? It's not electric, it's not gas powered, it's both. What is that called? Hybrid, like a Prius. Because you drive on gas when you need it, and then when gas is not needed, you use electric. And then when you go back to driving your gas, it recharges the battery. And every time you press on the brakes, the friction of the brakes recharges your batteries. Yeah, yeah. There's a lot of stuff in there that people don't know about. They say, "Oh, it's a hybrid, it's a Prius." No, the Prius I had, I loved it because it had two motors. When you press the gas pedal down, you have two motors pushing it: the gas powered motor and the electric powered motor. They both work in concert to make it go faster, and it had excellent. Because who do you think has faster acceleration, electric or gas? Electric by far. Because electric, when you turn the switch on, what happens? Light comes on instantly. Gas powered, you have to build up the power. So you have instant, it goes 100% force. Okay, so this is now we're going to buy a hybrid. What else do you look at? The prices. What do the price have to do with it? Budget, yeah. Not, yeah. Once you figure out, can it fit my budget? Then you look at, well, you're right, because if you shop in Dallas and Fort Worth area, the car prices are gonna be higher than if you go to a small town. If you're gonna buy a Chevrolet, don't buy in the city, buy it out in the country. Because they know people out in the country don't have much money, so they can't charge that much. The prices are gonna be dramatically different. Yeah, you have to do your due diligence and shop around. But budgets is the big thing. That's the first thing people look at is before I look at anything, how much of a car can I afford? That in itself is a whole problem. So you have to look at how much money you bring home each month. How much is your electricity? How much is your rent? How much is your satellite, your telephone? How much is your food? All that stuff. You have to look at all the stuff that you have to have each month. Now, how much do I have left over? That tells you what kind of car you can buy, whether it's brand new or used. Another thing you have to look at, your credit score. Each one of us can go to the same dealership and ask about the same car. We'll get different prices. We'll get different finance rates. Put your phone away. Because again, if your phone's more important than here, then stay home. Watch this whenever you want to. But if you're gonna come in here and play with your phone, don't bother me. Because it's kind of insult to me. So yeah, so seeing how much you can afford, your credit score is huge, which I think first off it's criminal. How are credit scores determined? Exactly. Too many things you can name. It's have you ever been late on a payment? They don't care why. It's just, bottom line, have you ever been late? And if so, by how much? Do you have enough too many credit cards that you have more credit than you can afford? I mean, you have access to money, but you can't use it because you can't afford it. Which never made sense to me. And so, in the penalties, if you miss a payment, your penalty is harsh. They'll send it automatically to a credit bureau, and then your score gets jacked. It gets ruined, dropped. And it takes about a year or two to bring it back up. But what about the upper echelon, the rich people who are late all the time? Do their credit rating get dinged? No, because they have a lot of money that say, oh, I could have paid it, but I just forgot. And it's not fair. The whole credit industry is so unfair. Yeah. Oh, yes. Again, it all started, look at the history of it. It all started by who? The politicians. A company, some companies said, yeah, hey, we're letting banks borrow money and they're going under. Let's have this credit rating. Oh yeah, if we do that, then the banks would charge more interest and then we get more money. And who do you think are the board of directors of banks and things like that? If not the politicians, the ex-politicians, then their families, the family members. And if you ever want to see a cush job where you have to do nothing, be a board of director of a big corporation. You'll get like a 6-digit salary just to be on the board, and you get multiple free trips a year because this year our board meeting will be in the Swiss Alps. We're gonna go skiing this year for a week. Bring your family, bring your friends on private jets. All of it is hush hush, all of it. And then again, we're all paying for it. Our credit union, our banks that we use, the companies that we use. You think that Apple cell phones really cost that much to make? No. But they charge you thousands of dollars. Why? Because they have you hook, line, and sinker. Everybody, because somebody said Apple's a good buy, everybody started buying it. Now everybody's buying Apples. What do you need a cell phone for? Talking on the phone? No, not anymore. Texting? Yeah, but is it really necessary? If again, you look at how much time you spend on your cell phone texting. Look at each month, how many text messages you've sent and received. If that doesn't scare you, look back at the messages you sent. Were any of those absolutely necessary? And think of how much time you spent doing that. So I mean, I'm sorry, I'm gonna get off my soapbox. But that's what we're getting as a society nowadays is we're getting it's that small crap. I mean, for Christmas time, what was the hot toy this past Christmas? Wasn't a toy, it was a cup, the Stanley Cup. You know why? Because one, which I hate the term, influencer had so many followers with so low self-esteem that they had to believe and listen to these people that know much more than they do. Said, oh, this is a good buy. So this is the hot item. So everybody want to go out and buy it. Once people started buying it, people started using the herd mentality. If you bought it, then I gotta buy it too. I don't want to be the only person that doesn't have one. It's no different than any other thermally insulated cup. If you want the word Stanley on it, get a pen. It's not the Stanley Cup from hockey. Most people who buy it don't even know what the Stanley Cup is all about. Never watched a hockey game in their life, but everybody rushed to buy it. Again, that's our, I'm trying to get you guys, do not be influenced by what these call people influencers. And if you do, get more self-control of yourself. Have more courage in yourself. What makes that person any better than you? Because you'll be faced this in your students when you start teaching them. And the younger they are, the more influenceable they are. So that's the scary part. And if somebody on TikTok or YouTube or whatever anybody's using at the time says, well, tomorrow is a no school day, we're going to skip because we're going to support this cause. Okay, I'm not going to school tomorrow. That's how people are. It's scary how easily manipulated people are. Everybody that uses that is dedicated to their cell phones is that way. Please be yourself. Again, I'm sorry, I'm getting off topic. Let's look at some examples here. Here's one. Here's an example. Why we need to experience multiple problem-solving methods. If problems are approached repeatedly in one way, a mindset is made. Think about that. If you approach a problem the same way over and over and over, a mindset is made. Don't believe me? All right, here it is. Spell the word spot 4 times in a row. Really quick, out loud. And now everybody in the class. What do you do when you come to a green light? Yeah, exactly. There you have an example. Is you did something repeatedly, and all of a sudden, even though you said stop, you didn't say spot. You said stop because you had the same letters. That's an example of repeating a pattern and getting stuck with it. Not being careful what you say. Also bring another solution. Never rush into a solution. Never rush into a solution. Take time to think about it. Even when somebody asks you a question, think about what they asked before you answer. Because once you answer, you can't take it back. So, okay, here's another one. A shepherd has 36 sheep. All but 10 died. How many lived? Are you sure?
Yes.
Yep. Because all but 10 died. That means 10 lived. If you get the answer wrong, that means you didn't read the question. And step 1, understand the problem. Before you give a conclusion, make sure you understand the problem. Oh, that's, yeah, let me go to these. The 4 steps of POLYA. The first step is understand the problem. What's that? No,
Oh,
yeah. Now, what are some examples of that? Understand the problem. For example, can the problem be stated differently? If you don't understand the problem, see if you can restate it. What is to be found? What is needed? Like you said earlier, think about everything you need. You have the plan. Now let's put together everything we need. What information oop, is obtained from the initial problem? First, you're given a problem. What does it tell us? Because the solutions are all usually always in the problem. And if anything's missing, what other information is needed? These are just some of the possibilities. This is to understand the problem. Is this the entire list? No, there's many more. Okay, step two. What was step two? Devise a plan. What does that include? Look for a pattern. Is there a pattern forming with what's given? Look at similar problems. As you said earlier, look at if you've done it before. What are the commonalities? What can I use from what I've done in the past to now? Look at simpler problems. What does that mean? Look at simpler problems.
Basically, it's like, I'm trying to solve like the long addition problem, look at one of them.
Yeah, or take that one and just break it up into small pieces. That's exactly right. That's where the order of operation comes in. If you're supposed to do parentheses, then just look at what's inside the parentheses. Only do that. Instead of looking at the big problem, look at one small piece of it. Make a table or list. Draw a graph or picture. Make a diagram. G. Use guess and check. Work backwards. In all sciences, STEM courses, whenever you get a problem, always draw a picture. Because if you can draw a picture of what the question is asking, then you understand it. Then you can look at, you start label things on there. What is this? What is this? What is this? Then you start putting together, look for an equation that puts it all together. Work backwards. You ever hear the term reverse engineering? Reverse engineering is just that, is I get to the solution, I work backwards. How do I know what I need to get to? How do I get to it? Let's break that up into smaller pieces. Let's go backwards, which is what's used, for example, the Japanese. After World War II, we gave them the plans to build a car, the Model T. We helped them build their factories. And then they took it from there. What they did, they took the plans they gave us. They said, hey, we know we want to get to a car at the end. Is this the best way of doing it? So they back engineered it. And that's where we get most of our cars now. Is this factory the best way it could be done? They back engineered it. Is this the most efficient way of doing it? No, they found other ways. So reverse engineering is a very powerful tool. Third method, a third step. Carry out the plan. And that's pretty much it. That's just carry out the plan, see what you get. But when you carry out the plan, what do you have to keep? Keep a record of what worked and what didn't. Why is that important? Go ahead, go ahead.
Oh, it's just like, like just mistakes that you did. If you found that one way works better than so you find like another step necessary that you take to your future problem.
Right. As the saying goes, those ignorant of history are condemned to repeat it. So if you know what you did in the past that didn't work, you're going to do it again. But you keep a record saying, no, we can't do this because we tried it one time and it didn't work. So, and then the last step. Review. Determine what worked, what didn't work. What were the issues you had that were unforeseen? How did you solve those? Always ask yourself, is this the best solution possible? The answer to that question is always no. Why is it always no?
For example, in my work in the country, every day is like a learning experience because I see minor things that can change. Why they
And is the concrete always the same, or do they come out with new stuff?
This is just the way to mix it. One day is like extra hard, one day is like tasty. It's just based on like prior experience.
And yeah, depending on the atmosphere, the weather, the temperature. So yeah, it's never the same. But again, another thing is technology is different. We're now, again, back to the history thing. It wasn't too long ago where they started building bridges across rivers. The problem they had earlier is the concrete would never settle. because they put it in the water, it dissolves. So where you know where they got the solution from? Back in the days of the Romans, thousands of years ago. The Romans figured out how to build these huge towers, these aqueducts that were going through rivers, and they didn't fall apart. They used volcanic ash with their mixtures. And then once it became hard, nothing could destroy it. Concrete, fast setting concrete. So there's always technology that's going to come and change with what you have. The basic premise may be the same, but the new things may make it better, faster, stronger. All right, let's look at some problems. I'm looking for my example sheet. Fill in the blanks. All right, another example. Fill in the blanks. How'd you get that? Fibonacci sequence. Yeah. Take the two before, add them together, you get that. Take the two before, add them, you get that. That's Fibonacci sequence. There's a pattern. Remember, it said look for patterns. Back in the 1600s, a young boy was named von Leibniz, not von Leibniz, Gauss. He was in Friedrich Gauss. He was in school. Remember, this is way before they had technology, any calculators and stuff like that. All they had was paper and pencil at best. He was super smart. This was when he was about fifth, sixth grade. He was getting tired of class and always used to correct the teacher and said, ruin the class for him. Finally, the teacher got upset, got tired of him and said, okay, go outside. Add all numbers from 1 to 100. Don't come back until you have the final answer. I ask you now to solve this. Add all the numbers from 1 to 100. This little kid solved it in less than 5 minutes. He went out, worked on it, came right back in, and ruined the teacher's day again. But this kid eventually grew up and invented a few disciplines of mathematics. So go ahead, add 1 to 100. See if you can figure out a pattern to do this. You could talk to your neighbors if you want and wake them up if they're falling asleep. So now, with that list I gave you earlier, how are you approaching this?
Like, and then, just like, so you know, how it's going. And then from there, you use your last number to come up with a formula, and then you can use your first number that it starts with the sequence, and then use the difference that it has, and then for the rest of the formula, but that don't have.
See, so you didn't think of it. So now, as I said, memorizing things are bad. Learning them are better. Because when you remember stuff, you forget. But if you learn them, you can apply them later on. But you're kind of there. But it's not the difference. No. Let's look at something smaller. Let's look at if we add 4 numbers. What does that equal? 4 plus 3 is 7, 9, 10. So it equals 10. What's that going to equal? So that's 10 plus 11 is 21. Now let's try to make it work. Let's look at this. This is how Gauss figured it out. He took the first and last term and added them together. He took the middle 2 terms and added them together. They both equaled what? So the first and last term equaled 5, and it occurs twice, so that's times 2. So we get 10. Let's try that again. 1 plus 6 is 7. 2 plus 5 is 7. 3 plus 4 is 7. So the first and last term equals 7, and it occurred how many times? So we know where this number came from. Where did these numbers come from? Adding the first and the last one. Where does this number come from? How do we figure it out? How do we get 3 for this one and 2 for this one? But yeah, how do we determine that? How many numbers are here? How do we go from 4 to 2? How many numbers are here? 6. How do we go from 6 to 3? No. Count how many. We use the letter N. That tells us how many numbers are on the list. There are 4 numbers in the list. If we divide it by 2, why 2? Because they're paired up. This tells us the number of pairs of numbers. We have 2 pairs because we took these 2 and these 2. That's where that number comes from. So it works again here. Here the number is 6. We have 6 terms. We divide it by 2 because they're in pairs. That equals 3. So he figured out our solution to this is if we listed them out this way, this a to the n is the last number in the sequence. This is the first one. If I take A1 plus AN, add those together, That's what gives us this 5 and the 7. I'll take the first and last numbers, add them together, and then multiply by half of the number that we have. So if we're going from 1 to 100, how many numbers do we have? We have 100, right? If we add the first and last number, what do we get? 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101. How many times do we do that? 50 times. So we have 101. We had 100 numbers and we divided by 2. So 101 times 5 is 505 with a 0 at the end. 50-50. You were that close. You didn't write it down, did you? You did in your head.
I'm trying to slow it down.
Okay. But just think about this. This kid invented this method 300 years ago. Or no, now it's 500 years ago. Pretty smart kid. So again, if you get stuck with them, try with smaller numbers. Look for a pattern. Let me see my next game I want to play. That won't take too long. Ah, here's one I like. It's called the magic square. Where's my magic square? Oh, I lost my magic square. I lost my number. Oh no. Let's see. Because in here, the magic square is this. You can only use the numbers 1 through 9. Only once. Each row, column, and diagonal must equal the same number. I have to get my numbers. Because I deleted my numbers in my square. Okay. Let's try this. This is 8. One, 3, and 2. Well, to speed this up, I'll give you that. Finished? What's this number? This number? Right. Because if you add up all these diagonals and all these rows and columns, they all equal 15. Oh, they're supposed to. Normally, the way this is done is I'd give you a blank square and I would tell you that the sums are 15. You would have to start with a blank slate and figure out the numbers. But I'll just give you some numbers. I'm trying to find some other ones here. Oh, here's one. Example. I have 83 cents. But fewer than 10 coins. There. I have 83 cents, but fewer than 10 coins. How many of each coin do I have? So how are y'all approaching this problem? Yeah, so I can have a quarter. I can have a dime, a nickel, and a penny. So here, got to create a table. And it has to equal 83 cents. So how would you begin this? What's that? Well, you have to get exactly 83, not close. Yeah, start with the highest numbers first. 25. How many quarters can fit in 83? That's 75 cents. So I have 83 minus 75 is 8. Can I have any dimes? Can I have a nickel? So minus 5. Okay, that equals 83. Is there any other way I can do that? Well, what if I only tried 2 of these? Actually, no, let's try with 3 of these. I have no dimes. What if I had no nickels? How many pennies do I need? That's 83 cents. But is that viable? Why not? How many coins are used? I need to have fewer than 10 coins. So I cannot, even though this equals 83 cents, I cannot use that. Let's try another one. If I drop this one, I only have 50 cents. This is 50 cents. So I have 83 minus 50 is 33. Can I have any dimes? 3. So no nickels and 3 dimes. That's equals 83 cents also. 3, 6, 8. So this one would work. This one would work. Let's try this. 2 of those. Let's try 2 of these. If I only have 2 dimes, I need to have how many nickels? And then 3 pennies. 2, 4, 6. That's 9. This one would work. So this question here is asking you not just find the only one, find me all possibilities. As long as I have fewer than 10 coins and equals 83 cents, I'm good to go. So you'd keep on going from there. No, we won't get it. Oh, you want to go see any more? Let's try. We have 2 of these. We can keep 2 of these. Only 1 of these. So we have to have 8 of those. Go make up that nickel. 10. This is not going to work. It's 83 cents, but it's too many coins. How about if we only had one, we had 2 quarters, 1 dime, or yeah, if we had 2 of those, we have no nickels. So we have 50, 60. We need 23 cents. Too many. So we can't. How about if we had 2, 1. So it's 50, 60, 83. This is exactly 10 coins. Does that one work? Why not? It said fewer than 10 coins. This is exactly 10 coins. So this one doesn't work. This one doesn't work. So what I would do if I assigned this to you as a homework assignment, I want to see all possibilities, not just the ones that work. Because you have to go through all the possibilities now and see which ones work, which ones don't. Okay, last one. Tell me how much the last one would cost. 3 burgers cost $30. This is your exit ticket. So when you finish this, bring it to me. If you get it right, you can leave. Nope. Mhm.
Hold on, right here.
Mhm. Mhm. Very good. Mhm.
No?
No, I see the mistake you made. Mhm. Okay, go ahead and write down the picture or take a picture of it, and we'll talk about this on Monday.
That's the only way I can see it.
Nope. There's another way you can see how to do it. You're overlooking one thing. And you're gonna kick yourself when you see it. Yes. But we have to give the room up to the next class.
Oh.
Yeah, I'm gonna see about if the room, my next class, if that room is open for this time period, that way we can have this kind of stuff at the end. Okay, so take a picture of it and then we'll discuss it on Monday. Today's Wednesday, right? I'm getting my times mixed up already. And I thought you guys were gonna get it done. And you guys are all so close, so close. And when you see it, you'll hit yourself.
I'm telling two, but.
Right? Don't say anything. Bye, guys.